Uh, Timing diagram of 8085 we are going to discuss. So what is timing diagram? This is the one of the best way to understand the process of the microprocessor. The timing diagram usually represents the clock cycle, its duration, the content of the address bus, data bus, what type of operation through which the processor is going on, the different types of operations such as whether it is a read operation, write operation, status signal. So all these signals which are required for the execution of a particular instruction, it is being represented in the timing diagram, or you can say that it is a kind of a representation which gives the information related to every aspects through which the processor has to go while executing a particular instruction. Now, before going to discuss the timing diagram, we should first discuss that how the time is being measured as far as the execution of any instruction is concerned. So, what happens during the normal operation? The microprocessor sequentially fetches the instruction. So, the sequence in which it performs, it fetches, decodes and then executes one instruction after the another until the halt instruction is executed. So, this fetching, decoding as well as the execution of a single instruction is going to constitute the instruction cycle. Now, this instruction cycle consists of 1 to 5 machine cycles, or you can say 1 to 5 read or write operation which used to happen between the processor and the memory, or the processor between processor and the input output devices. Now, every memory or the peripheral requires a particular time period, and that time period is called machine cycle. So, machine cycle is nothing but the number of times the processor has to go to the memory or the input output device, the number of time it goes for executing the various operations, it is known as machine cycle. And number of machine cycle is going to constitute the instruction cycle. So, you can say that in other words, whenever we want to move a data in or out of the microprocessor, a machine cycle is required, and each machine cycle consists of 3 to 6 clock periods, or the 3 to 6 clock cycles. That clock cycles are known as T states. So, as far as the definition of T state is concerned, one subdivision of the operation which is being performed by a processor while doing the execution of any instruction is known as T states. For example, as I told you that whenever the processor is going to execute any instruction, it fetches that instruction, decodes it as well as executes it. Now, this decoding, execution, the decoding, fetching, decoding and execution of the instruction, of course, it constitutes instruction cycle, and for that particular instruction cycle it requires many times to go to the input output device or the memory device to fetch, which is measured in terms of the machine cycle. And while doing this, whatever signals are being generated, so whatever a single subdivision of that particular operation which is being performed in a particular time period is known as T states. So, we can say that the one instruction cycle consists of 1 to 5 machine cycle, and one machine cycle consists of 3 to 6 clock periods or clock states. Now, we have 7 different types of the machine cycles which are which used to happen in 8085. We have 3 status signals, that is input output oblique memory, S1 and S0, and based on the distinction between these status signals, we are able to distinguish the different machine cycle. Now, these signals are generated before the machine cycle starts, or in the beginning of the machine cycle, and remain valid for the duration of the life. Now this is the table which shows that what are the different machine cycle operations. The different machine cycle operations are opcode fetch, memory read, memory write, input output read, input output write, interrupt acknowledge, bus ideal, and at a particular time what will be the status signals and what will be the control signal, it is represented in the table. Suppose it is opcode fetch, so opcode fetch is already done, always done with the memory. Memory is negatively activated, so this is 0, so this is 0, and S1 is 1, S0 is 1. Read signal will be 0 because we are doing the reading process. Write signal is deactivated, it is 1. INTA has no relevance in this particular, so it is 1. So this is the way. Similarly, memory read operation. So in memory read operation, we are doing memory operation, so it is 0. S1 will be 1, S2, S0 will be 0, and since it is a read operation, so read will be 0 and write will be 1. So in this way, the different machine cycle used to be performed. Now opcode fetch is a kind of an operation in which any opcode related to the instruction is being fetched. Memory read is a kind of an operation in which we want to read any data from the memory. Memory write is a kind of an operation in which we are writing something into the memory. Input output read operation is an operation in which we are reading something from the input output. Similarly, input output write is the kind of a process in which we are writing something, mean the processor is writing something on the input output. INTR acknowledge, whenever any INTR signal is being received by processor, it used to acknowledge it through the INTR acknowledge signal, and there are certain time in which the bus remains ideal, it does not have any work. So depending upon the different machine cycles, we have different status signal. Now we are going to start now the timing diagram, but before going to the timing diagram, first let us know that what are the how the signals are being represented. Now as you see, we are talking about now the clock signals. Now in the 8085 divides the clock frequency provided by x1 and x2 as the input by 2, which is called the operating frequency. So all the operations, whatever is done by the 8085, are synchronized with this operating frequency. So therefore, in the timing diagram, operating frequency clock is always shown on the top, and then the signal are shown with the reference to that operating frequency clock. So ideally the clock signals should have this square wave, but this square wave, the ideal square wave is shown in which there is 0 rise time and 0 rise time. This is 0 rise time and this is 0 false time. But in practice, we don't get the 0 rise time as far as the practical aspects are concerned. This is the practical one in which we don't have 0 rise time and 0 fall time. There are certain finite rise time and the fall time. As you can see here, this is the rise time. So this is the fall time. See, this is the fall time and this is the rise time. So this is about how the clock signals are being represented. Now the single representation is being done with the help of this diagram. It can be very easily clear. Now single signal is represented by a single line, and it may have the status either logic 0, or it will have the status the logic 1, or it is the tri-state. Now change in the state of the clock, change in the state of the signal takes a finite time, and hence the state change of the signal is represented with the finite rise time as well as the finite fall time. This is rise time, fall time. Now this is how the single line signal representation is being done. Now group of signal. In group of signal is also called a bus. For example, address bus, data bus. And to avoid the complication in the timing diagram, these signals are grouped together and shown as per the figure. It is the group representation. Now, in this group representation, individual state is not considered, but the group state is considered, and change in the state of the single line changes the state of the group. Now, it is represented by a cross as shown in this particular diagram of the slide, and this tri-state condition of the group signal is shown by the dotted line. Now, two straight line represents the valid state oblique stable state. This. Now, in microprocessor system, the activation of the signal or the oblique the signals depends on the state of whether signal or the signal. Now, we have a certain situation arises in the timing diagram, and it will be shown in the timing diagram. So, we used to use certain specific symbol which will be representing the change of the state. So, we have four possibilities in this particular case. The first possibility is the activation of the signal with the change in the state of other signal, activation of the signal with the change in the state of other signals. Now, the first one is activation of the signal with the change in the state of other signal. Now, see, this is the activation of the signal with the change in the state of other signal. Now, this is the activation signal. This is the activation signal, and this is the other signal. So, what we try to find out that how the activation of the signal with the change of the state of the other signal is being done. Now, this is being changed, so it is going to change this, and this is going to change, so this is going to change this. The second one is the activation of the signal with the change in the state of other signals. Now, in this case, this is going to make changes in the two signals. Similarly, we have another diagram which will be representing that the activation of the signals, once many signals are being activated by the change of only one signal, and many signals are being activated with the change of different signal or many signals. So, this is the case in which there is many signals are going to change the state of a single signal, and this is the case in which many signals are going to change the many other signals. Now, the signal timing, we have many operations which has to be performed while reading or writing process, whatever the processor is going to do, and the one of the important signal lines which are required to fetch or to read the memory or the input output device is the ALE. ALE stands for address latch enable signal, and this signal is active high signal. So, it is activated in the beginning of the T1 state. Now, see, it is activated in the beginning of the T1 state of each machine cycle, and it remains active only in the T1 state as represented in this particular diagram. So, ALE signal is activated in the beginning of T1 in every machine cycle, and it remains active only for one T state, that is T1. Now, the second one is the A0 to A7, that is lower byte address. Now, this lower byte of the address is available on the multiplexed address oblique data bus, that is AD0 to AD7, and during T1 state of each machine cycle, meaning that the first state of the each machine cycle, it remains active. Now, you can see whatever we are going to put as the lower order address, it is activated in the T1 with the first T state of the machine cycle 1, every machine cycle, and it remains active up to the only T1 state. Now the data bus. Now the data from the memory or the input output devices and from the microprocessor to memory or input output devices is being transferred during T2 and T3. Whatever data transfer has to take place, it used to transfer during the T2 and the T3 state. So therefore it is important to note here that the read machine cycle data will appear on the data bus during the later part of the T2 state as it is shown in this particular figure. Whereas whenever we are doing the write operation, in the write cycle, data will appear on the data bus at the beginning of the T2 state. See, so there is a little bit difference. So the to read data from the memory or the input output device, it is necessary to select the memory or the input output device first. After the selection is being done, device will put the data on the selected location from the selected location to the onto the data bus. Now this action needs a finite time, and whatever time which is used to do that is known as the access time. So in case of write cycle, data is available in the register of the microprocessor, and it can be put into the on the data bus with the 0 access time, because memory and the input output devices are a little bit slower than the working of the 8085 is concerned. So whenever we are doing the write operation, the data from the processor will be immediately available on the data bus, but whenever it is the memory read operation or input output read operation, there are certain access time which is required to get the data from the memory or the input device on the data bus. Then we have a A8 to A15, that is higher order address. Now the higher order address, the higher bytes of the address is available on A8 to A15 during the T1, T2 and T3. This T1, T2, T3 state of the machine cycle. So this is about the higher byte. Then we have certain status signal which is also used. These signals are called status signal because it represents the status, that what kind of operation it is being performed, and it is the combination of the signals. It consists of input output oblique memory S0 and S1. So this signal decides the type of the machine cycle to be executed, and they are activated in the beginning of T1 of the machine cycle and remains active till the end of the machine cycle. It remains active till the end of the machine cycle. So since it is a group of signals, so it is represented as a group, which I have shown in earlier slide, how the group of signals are being represented. And in between that, we used to write, if it is opcode fetch operation, so it is represented by input output memory is equal to 0, S0 is equal to 1, S1 is equal to 1. If it is memory read operation, then S0 will be 0 and S1 will be 1. Now the read and write control signals. Now these signals decide the direction of the data transfer. When read signal is active, the data is transmitted from the memory to the processor, and when write signal is active, data is transmitted from the processor to the memory or the input output. Both signals are never active at a time. There will be only one operation which is possible at a time, either reading operation or the write operation. So we know that the data transfer in 8085 took place only in T2 and T3. So these signals are activated during T2 and T3. So there is no need to activate this signal in T1 because data will be available only in between T2 and T3. That is why the read signal, or if it is a write cycle, write signal, both the signals are is activated only at the interval of T2 and T3. Now, as I mentioned that there are many kinds of machine cycles, so we have to know the timing diagram of the individual machine cycle. तो सबसे पहले we are going to discuss about the opcode fetch cycle. Now this first machine in this opcode fetch cycle, what used to happen, we are fetching the opcode, that is why it is called opcode fetch cycle. Now the first machine cycle of every instruction is opcode fetch cycle, in which the 8085 finds the nature of the instruction to be executed, what type of instruction it is. Now in this machine cycle, what the processor does, it places the content of the program counter on the address bus, and through the read process, the opcode is going to be opcode of that instruction is going to be read. Now as far as the length of this machine cycle is concerned, it is not fixed. It varies from 4T state to 6T state as per the instruction. So let us discuss only the general opcode fetch cycle, in which it normally takes the 4T states. So what used to happen in step number 1, then it will be more clear. Let us discuss the step number 1 of the opcode fetch cycle. So in step number 1, what happens in T1 state? In T1 state, 8085 places the content of the program counter on the address bus. So higher order bytes of the program counter is placed on A8 to A15, and the lower byte of the program counter is loaded on AD0 to AD7. Now this AD0 to AD7 remains active only up to the T1 state. So thus the microprocessor activates the, as well as in the T1 itself, the ALE signal is being activated with the active high, and it remains active only for the 1 clock period. So in T1, 8085 also sends the input output oblique memory signal along with the status signal. Input output memory specifies whether it is a memory operation or the input output operation. S1 and the condition of S1 and S0 represents whether it is a read or write or the opcode fetch operation. So therefore in this particular case, since it is a opcode fetch operation, so input output memory is 0 and S0 is equal to 1 and S1 is equal to 1. Now what happens in T2, state T2? In T2, the lower order address disappears. The lower order address disappears from AD0 to AD7 lines, and in T2, since the data will be available only at T2 to T3, so we provide the read signal at the time of T2. The read signal low is enabled to enable the address memory location. So the memory device then places the content of the address memory location onto the data bus in this T2. What happens in T3? During T3, the 8085 loads the data from the data bus into the instruction register and raises read signal high, which disables the memory device. Now this read signal is activated in T2 and it is deactivated in T3, and so whatever is the address memory location, whatever is the content of that, it is placed in T3. And what happens in state T4? In state T4, the microprocessor decodes the opcode on the basis of the instruction received, and then decides that whether to enter into the go forward for the T5 state or to enter into the state of T1 of the next machine cycle, and one instruction byte those operate on the 8-bit data are executed in T4. So it is the T4 whenever it is going to decode and execute, then only it decides whether the next T state will be the in continuation or it will be the first T state of the next machine cycle. So this is all about the opcode fetch cycle. Then memory read cycle. In this memory read cycle, the 8085 executes the memory read cycle to read the content of the read write memory or the ROM, and the length of the machine cycle is 3T state. Now in this machine cycle, the processor usually places the address on the address lines from the general purpose or from the program counter, and through the read process it reads the data from the addressed memory location. So this is always given. So what happens in case of T1? In T1, the address will be available. Higher order address bus is higher order address is available on the higher order address bus. Lower order address bus is address is available on the lower order address bus, and it remains activated only one. ALE signal is activated. It is also enabled up to T1, as well as the input output memory and the status signals are being activated. Now input output memory S1 and S0, these group of signals are activated through through the machine cycle itself, but AD0, AD7 to AD0 and ALE signal is activated only for the first T state. Now since we know already that data will be available only with the T2 and T3, so T2 will be, the read signal will be activated in the T2 state, so that whatever is the address memory location from where the data will be placed on the data bus, and during T3 the whatever has been specified, according to that the processor processes the information. So this is about the memory read operation or the memory read cycle. Similarly, same thing happens with the memory write cycle. In this also we have only 3 T states. The 8085 executes the memory write cycle to store the data into the memory. The length of this is again 3 T state, T1, T2 and T3. In this machine cycle, the processor places the address on the address lines through the program counter. It stores the data into the address memory location, and what happens in T1? T1 again the same thing happens. Lower order address on the lower order address bus, higher order address on the higher order address bus. ALE signal is going to high, and all the activation signal, input output memory and the status signal remains is enabled, and write signal is enabled in the T2. And so during in between T2 and T3, whatever is the content of microprocessor register, that will be copied into the memory or the. So this is memory read or memory write cycle. Now input output read cycle. Now input output read and the input output write machine cycle are similar to the memory read and the memory write cycle, except that input output memory signal is high, and input output read and the input output write machine cycle. During input output read and input output machine write machine cycle, input output oblique memory signal is always high. High why? Because the same signal is used to indicate whether it is an input output operation or it is a memory operation. So this is the input output read cycle, in which we are taking only 3 T state. Similarly, the lower order address or higher order address as well as ALE signal is, all these signals are activated in T1, and the read signal is activated in T2, and in between T2 and T3 you will be able to get the data either for the reading process or for the writing process. So this is the input output read cycle, and this is the input output write cycle. Again it is 3 T states it is going to take. Now if a particular instruction has both the operations, that is opcode fetch as well as the memory read, then what will happen? Then the timing diagram will be little bit lengthier. Suppose we are taking the example of an instruction MVI A30. MVI is a kind of instruction by which what we are doing, we are putting 30H into the accumulator. So first of all, this is 2 byte instruction, 1 byte for the opcode, another byte for the operand. So first of all, it will taking the so this instruction will take 2 machine cycle, the first machine cycle and the second machine cycle. In first machine cycle it will be fetching the opcode, and in the second machine cycle it is fetching the or it is reading the data. So first machine cycle will have 4 T states, and the second machine cycle will have 3 T states. And in a very similar fashion, in the first machine cycle, in first machine cycle, in its first T state, what happens? Higher order address, lower order address, ALE signal as well as the status signal, all are activated. Lower order address bus and ALE signal is activated only for 1 clock period, and during T2 the read signal is activated, and during T2 and T3 the opcode will be available to the data bus. and in T4 it is being decoded and executed by the processor, and in the next machine cycle again higher order address and the lower order address is activated along with the ALE signal and the status signal, and in the second T state of the second machine cycle read signal is being activated, and during T2 and T3 the data will be available, and at the end of the T3 30 will be copied into the accumulator. So this is how the representation of the execution of the individual instruction can be represented by the help of timing diagram.